Hi, this is the second lesson in projectile motion. Already I discussed few questions in my previous video, the first lesson. So I'll give you the link of that first lesson in the description part of this video. Okay, we'll go to the question. First question in this second lesson. This is about cricket. A bowler throws a ball horizontally at a velocity u0 from a height of 2.3 meters above the ground. The ball moves and hits the ground at point P, and then it bounces off and just passed over the stumps horizontally. That's the way the question says. The ball is just passing over the stumps horizontally and hits the ground at a distance of 3.5 meters from the stumps. So the first part, find the time taken to reach the stumps from P. Okay, so they asked me to find the time taken to reach the stumps from P after hitting the ground. Okay, so the question says it's passing over the stumps horizontally on its highest point. Right, so the velocity, the vertical component of the velocity here will be equal to 0. We know if the initial point P and if I name this point Q, if they are along the same horizontal line, then the time taken to reach the highest point from P will be same as the time taken to reach Q from the highest point, because it's symmetrical about the highest point, the left side and the right side of the motion. From about the stumps, it will be symmetrical. So the time taken to reach the highest point from P will be same as the time taken to reach Q from the stumps. So here the question is the time taken to reach the highest point from P. We don't know anything. We don't have any data. We don't know the velocity. We don't know the angle, nothing at P. So better, we will find the time taken to reach Q from the highest point. That will be same as the time taken to reach the highest point from P. So first part, I'll consider the motion from stumps to point Q, downward direction. I'm going to use S equal ut plus half at squared. So it's passing over the stumps on its highest point, means the velocity will be horizontal direction. The vertical component will be equal to 0. So I can say S is 0.71 meters. That's a vertical displacement. The vertical initial velocity is 0 plus half into 9.81 t squared. Find the time. So the time will be equal to 0.38 seconds. That's the time taken to reach the ground Q from the highest point. That will be same as the time taken to reach the highest point from P. Right. Second part. Find the velocity. So not speed. Velocity means I should tell the direction. Direction, we can give it in terms of angle. So the velocity at which it bounces off from the ground, I can say V1, the angle theta. Okay, find the velocity at which the ball leaves the point P. Right. So for that, I know the vertical displacement 0.71 meters and the velocity at the highest point in vertical direction, the vertical component of the velocity just above the stumps will be equal to 0 because it's the highest point. So I'm going to consider the motion from P to stumps, this direction vertically. So I can use V square equal U square plus 2AS. So vertical component velocity above the stump will be equal to 0. So 0 equal V1 sine theta holding squared plus 2 into minus 9.81 because I'm using upward direction into S will be the height of the stump 0.71. Okay, so from that I can find the V sine theta, the vertical component of the velocity, I can find it. V1 sine theta, I can find it. Bring it to the left and take the square root of it. So V1 sine theta will be equal to 3.73 meter per second. You can take this as equation 1. Right. So this, I told that this line is symmetrical. So the displacement on the right side from the stumps will be same as the displacement from P to the stumps on the left side, symmetrical. So this displacement also from here to here, this displacement also 3.5 meters. Okay, so this displacement also 3.5 meters. So I can use horizontally for the motion from P to the highest point. S equal ut plus half at squared. S is 3.5. Initial velocity will be v1 cos theta into time is 0.38 plus horizontally no acceleration. So from that I can get v cos theta, v1 cos theta I can find it. That will be equal to 9.21. That will be the second equation. Right, divide the second equation by the first equation by the second equation. v1 sine theta divided by v1 cos theta. That will be v1 will get cancelled. So tan theta will be equal to 3.73 divided by 9.21. So from this find the theta will be equal to 22 degree. That's the angle, that's the direction. Substitute this value of theta in one of these equations, we can get the v1. So if I substitute this in the first equation, v1 sine 22 will be equal to 3.73. From that, find v1. That will be equal to 9.96 meter per second. So the velocity at which it bounced back is 9.96 meter per second at an angle of 22 degree to the horizontal. That's the answer for the second part. Okay, third part, find the time taken to reach the point P from the bowler. So that is nothing, vertical displacement 2.3. The ball was released horizontally, so its vertical initial velocity will be equal to 0. So the third part, I can use from the bowler to P, I'm going to use vertically downwards, S equal ut plus half at squared. So S will be 2.3 meters. Initial velocity vertically 0 because ball was released horizontally, plus half into 9.81 t squared. Solve it. We'll get the time. That will be 0.68 seconds. Fourth part, find the initial speed u0. So it's thrown horizontally, so we know the direction. So I don't need, so that's the reason they are using the word speed, not the velocity. We know the direction is horizontal. So find the initial speed u0. So consider the motion from the bowler to P horizontally. So from the position of the bowler to the stumps is 20 meters. This is 3.5. So from the position of the bowler to the P will be 20 minus 3.5. That will be 16.5 meters. So horizontally use S equal ut plus half at squared. S is 20 minus 3.5 equal initial velocity speed u0 into time is 0.68. Horizontally there is no acceleration, no drag force. We don't consider that drag force. So solve it. You will get the initial velocity 24.3 meter per second. Okay, second question, it's on a slope, right? The ball is projected horizontally from a height of 3 meters just at the upper edge of a slope that makes an angle 20 degree with the horizontal line at a velocity of 12 meter per second. It was projected horizontally from the top edge of the slope at 12 meter per second. The question is, by using proper calculations, deduce, will the ball hit the ramp or will it go out of the ramp? That's the question. So there are two possibilities. The ball can hit the ramp or it can move out of the ramp and hit the horizontal floor. So that's the question. We need to find it by using proper calculations. Okay, this question we can do answer in two different methods. Okay, first method I'm going to take like this. I don't know whether it's going to hit the slope or not, but I'll take like this. If it is not hitting the slope, that means it moves out of the slope, something like this. When it hits the ground out of the slope, then its vertical displacement will be equal to 3 meters downwards. Right? So during that time, I will calculate the time taken to complete vertical displacement of 3 meters. That means if it is not hitting the slope and hitting the out of the slope, the vertical displacement is 3 meters. I am going to find the time taken for that motion, right? Then I will calculate the horizontal displacement from the edge of the slope, how much it moved horizontally. Then, since I know the angle, I can calculate this length also. This length also I can calculate, let it be x. Then, the horizontal displacement is greater than x. That means the ball will hit out of the slope. So that's the idea I'm going to do in my first method. Okay, so vertically downwards, S equal ut plus half at square. The ball was projected horizontally. So the vertical displacement 3, initial vertical loss is 0, half into 9.81 t square. Find the time taken. That will be equal to 0.782 seconds. Okay, that means I'm not sure whether it's hitting or not, but in case if it is hitting out of the slope, it has to fall vertically 3 meters. How long will it take? That I found it 0.782 seconds. Now I'm going to find its horizontal displacement. If it is hitting outside, what will be its horizontal displacement for this given velocity? So horizontally use S equal ut plus half at squared, that is 12 into 0.782 horizontally, no acceleration. So its horizontal displacement will be equal to 9.4 meters. Right. Now, if it is hitting the slope, then its horizontal displacement, if the ball is hitting somewhere here, then its horizontal displacement for this particular velocity, that should be smaller than this length x. I will find the length x, so tan 20 will be equal to 3 over x. Find the x, that will be equal to 8.24 meters. So that means its actual horizontal length of the slope is 8.24 meters. For this particular velocity, when it completes a vertical displacement of 3 meters, its horizontal displacement will be 9.4 meters. That means actually when the ball moves vertically downwards 3 meters, it will move a distance more than the length, horizontal length of the slope. The base of the slope is 8.24. This length is actually its horizontal displacement is greater than length of the base of the slope. Therefore, it will hit out of the slope. So I can say since 9.4 meters greater than 8.24 meters, 8.24 is the length of the base of the slope, the ball will hit out of the slope. Okay, the second method, I will find the x. Already I found it in my previous first method. Right, I'll find the x first. Right, then what I'm going to do, I will find the time taken to complete horizontal displacement, which is equal to x. I already found it in my previous part as first method. The x will be equal to 8.24 meters. So I will find what's the time taken to complete a horizontal displacement of 8.24 meters, right? Then I'll calculate the vertical displacement during that time. Say there are three different possibilities. If the vertical displacement of the ball when it completes a horizontal displacement of 8.24, that is the x. If the vertical displacement is less than 3, that means the ball is somewhere here. The ball is just above this edge, but its vertical displacement is less than 3. It has fallen a height smaller than 3. So that means it will continue its motion and hit the ground, not the slope. If the vertical displacement when the horizontal displacement is 8.24 meter, that is this length. If the vertical displacement is 3, that means the ball will hit at the edge of it here, right? If the vertical displacement is greater than 3, that means the ball is already hitting somewhere like this. So that means it has a chance of moving below the horizontal line, but it can't move. That means it is hitting the ground, the slope somewhere here. So there are three different possibilities. We will find how much the vertical displacement of the ball when it completes horizontal length, that is x. I can find the x by using tan 20 equal 3 over x. So x is going to be 8.24 meters. Okay, so I'll find the time taken to complete this horizontal displacement, 8.24 meters. I'll find the time taken. So horizontally use x equal ut plus half at squared. So 8.24 equal 12 into t plus horizontally no acceleration, is it? So the time will be 0.687 seconds. That's the time taken to complete horizontal displacement of 8.24 meter. What is 8.24 meter? That's the length of the base of the slope. Okay, we'll find the vertical displacement during this time. Vertically downwards, if I use s equal ut plus half at squared, I already showed the three different possibilities. The vertical displacement can be less than 3 meters. When it completes horizontal displacement, the ball is here. That means it can further move and hit the ground, not the slope. If the vertical displacement is 3 meters, it's going to hit the edge of the slope. If the vertical displacement is greater than 3 meters downwards, that means it has already hit the slope somewhere here. Okay, so we'll find the vertical displacement. That is going to be 0 because it was projected horizontally, plus half into 9.81, 0.687 squared. So you will get that will be that value will be equal to 2.32 meters. That means 2.32 meters is less than 3. So that means when the ball completes a horizontal displacement of 8.24 meters, it has fallen only 2.32 meters. That means the ball is somewhere here. This much of gap is still there. So it will move further and hit the horizontal floor, not the slope. So I can say since 2.32 meter, that's the vertical displacement, less than 3 meters, the ball will not hit the slope. Okay, so actually there are three methods. There's one more method I can approach the same question. So this is the idea. Now, for example, when we consider projectile motion on a horizontal floor, right? An object is projected from here. these 2 points are on the same level, when we consider the displacement perpendicular to this line. So imagine if I call this PQ, the displacement perpendicular to this line PQ will be equal to 0 when the projectile lands at Q, right? P and Q are the lines connecting the initial point and the final point. So when the projectile hits the Q, the vertical displacement, what do you mean by vertical displacement? The displacement perpendicular to PQ will be equal to 0. So the same way, when I consider the slope on a slope, if something is projected at an angle like this, and if it follows a path like this on the slope, and if I name this x and y, so if it moves from x to y, when the projectile moves from x to y, the perpendicular distance, here we don't say perpendicular displacement, we say displacement perpendicular to xy. The displacement perpendicular to xy will be equal to 0. Here we normally call vertical displacement equal to 0, but here we don't say vertical displacement. The displacement perpendicular to xy will be equal to 0 when the projectile hits y from x. I'm going to use that idea as a third method. Okay, so method 3, I'm going to use the displacement along the line PQ. Right, when the ball reaches, say, I don't know whether it's hitting the slope or not, but if it hits the slope at point Q, then its vertical displacement, its displacement perpendicular to the slope will be equal to 0, not the vertical displacement. The displacement perpendicular to the slope will be equal to 0 when I consider the motion from P to Q. So I'm going to consider the motion in right angle to the slope PS. S is the point where the slope is ending. Q is the point I'm taking, it's hitting the slope at point Q, but we don't know whether it's hitting or not. I'm going to find the length PQ. That's the purpose of this calculation. I'll tell you the method first. I'm going to find the length PS, right? By taking the displacement perpendicular to the line PQ, I can find the time. Then I'll find the length PQ. Then I will find the actual length of the slope PS. If the line PS is smaller than the displacement along the slope down PQ, that means the ball will hit out of the slope. We'll see that. So first I need to find the time taken to travel from P to Q. So I'm going to use the equation perpendicular to the slope. This direction I'm going to use. This is 20 degree, so the arrow is perpendicular to the slope. S equal ut plus half at squared. So the displacement will be 0 perpendicular to the slope. Right, so initial velocity, how much? It was projected horizontally. So this angle is 20 means, this is 20. This angle is 20 because alternative angle. So perpendicular to the slope, it will be 12 sine 20. Is it 12 sine 20 is the component of the initial velocity perpendicular to the slope. The time I need to find plus half. Okay, G, the gravitational acceleration is vertically downwards, but I am using it perpendicular to the slope. So that will be G cos 20 downwards. Can you see? G cos 20 downwards. I am using upwards. So that must be minus 9.81 cos 20. G cos 20 downwards. So I put minus into t squared. So I can divide the whole equation by t. So you will get 0 equal 12 sine 20 minus half into 9.81, 4.905 cos 20 t, because I divide by t. Okay, so find the t. You will get t is equal to 0.89 seconds. Okay, this is the time taken to move along the slope a length PQ. We don't know the length PQ. We will find the length PQ. So for that, I'm going to use along the slope down at 20 degree. Along the slope down, I'm going to use S equal ut plus half at squared. that is PQ. Along the slope down, the length it's moving is PQ. So I need to find the length along the slope down, that is 12 cos 20. Okay, so the displacement PQ, initial velocity 12 cos 20 into the time we know 0.89 plus half into acceleration. When we consider along the slope, this is G. Along the slope, it will be G sine 20 downwards along the slope down, G sine 20. So that is 9.81 sine 20. I am also using that equation downwards along the slope, so that will be positive along the slope down. 9.81 sine 20 into 0.89 square. Okay, so solve this. You will get the length 11.4 meters. So that means the point at which it hits the slope from the initial point will be 11.4 meters. So according to this height and this angle, we will find the length PS. So that is, we can find it by using sine 30. Sine 30 will be equal to 3 over PS. So PS will be equal to 8.77 meters. That is smaller than the range of the ball along the slope down. Range of the ball along the slope down is 11.4 meters, but this length is 8.77 meters. That means the ball will hit the slope, ball will hit the ground out of the slope. So I can say since PS less than, that is 8.77 meters, PS less than 11.4 meters, that is range of the slope, the ball will not hit the slope. Okay, so in this question, this is the third question. So in this question, a ball is projected from the bottom of a slope. The slope is making an angle 25 degrees with horizontal line. The ball is projected at a velocity of 12 meters per second, and it makes an angle of 55 degrees with the horizontal line. Okay, so the ball moves on a projectile path. The question is, now when the ball reaches the highest point, so will the ball hit the slope? It's a larger slope, along a slope. So will the ball hit the slope before it reaches the highest point, or will it be able to reach its highest point without hitting the slope? So the idea, so that depends it like this. This is the path. The ball can have a path like this. This is the highest point, right? So the ball was projected from here at 55 degree to the horizontal. But if the slope is something like that, we don't know the length of the slope, but if the slope is something like this, right, before reaches the highest point, the ball will hit the slope. But if the slope is something like this, ball will reach the highest point before hitting the slope. What will happen? That's the question. Okay, so there are two possibilities. As you can see the diagram. So if the slope is like this, the ball will reach the highest point here, but before that, it's going to hit the slope. So it will hit the slope here. But if the slope has an angle like this, 25 degree, we are not measuring and drawing, so just I am drawing it. So if the slope is something like this, what will happen? The ball will be able to follow its path, passes its highest point, later only it will hit the slope if the slope is longer. Right, so the idea is like this. Okay, I'm going to find the maximum height of the ball above the ground. So I will find, this is the horizontal line. So I will find this height, the maximum height of the ball Then we can use, highest point, the vertical component of the velocity will be equal to 0, Vv equal to 0. So I can find this maximum height that could be reached by the ball if the slope is not there. Imagine the slope is not there, the ramp is not there. So how much will be its highest maximum height from the initial point? Then we can find it vertically by using v squared equal u squared plus 2as, right? Then I'm going to find the time taken to reach the highest point. If there is no slope, okay, I'll find the time taken. How long will it take to reach the highest point? I can find it by using vertically v equal u plus at. I can find how long will it take to reach the highest point, right? That also I can find. So h I know. I know the time taken to reach the highest point. Then I have to find what will be the height of the slope. What will be the height of the slope? I don't know whether the slope is like this or like this. We don't know. But what will be the height of the slope from the horizontal line when the ball has horizontal displacement which is at its highest point? So I will find the height of the slope h. Height of the slope when the horizontal displacement of the ball is equal to, when it is at the highest point, when it has that length, what will be the height of the slope? Actual height of the slope, I will find it. If the height of the slope is smaller than the maximum height of the ball, that means the ball will not hit the slope. Understand? So that's the idea I'm going to do. So when it is at the highest point, the velocity is 0. So I'm going to find the height. First, the maximum height reached by the ball, v squared equal u squared plus 2as in vertical direction. Vertical component velocity is 0 at its highest point. That will be 12 sine 55 all the squared plus 2 into minus 9.81 times h. Find the maximum height that could be reached by the ball if the slope is not there. That will be 4.92 meters. Okay, so I will find now the time taken to reach the highest point if the slope is not there. V equal u plus at. I know at the highest point the velocity is equal to 0. Initial velocity will be 12 sine 55 minus 9.81 t. Find the time. So the time will be equal to 1 second, 1.00 seconds. So it's exactly 1 second. So the time taken to reach the highest point will be equal to 1 second. Okay, so I'm finding its horizontal displacement. The ball is at its highest point. What will be its horizontal displacement? What could be its horizontal displacement? S equal ut plus half at squared horizontally. So that will be 12 cos 55 into 1.00 horizontal, no acceleration. So if it is reaching its highest point, then its horizontal displacement will be equal to that horizontal displacement. We can find it by using, that will be equal to 6.88 meters. So that means this will be 6.88 meters. Okay, now I know the slope of the angle made by the slope, the ramp, that is 25 degree. What will be its height when the horizontal displacement of the ball 6.88 meters? What will be the actual height of the slope? I know when the ball completes a horizontal displacement of 6.88 meters, the ball's vertical displacement is 4.92 meters. Is it? When the ball has horizontal displacement of 6.88 meters, its vertical displacement is 4.92 meters. I'm going to find the height of the slope when the horizontal length is 6.8 meters. So this height I am going to find it. So this I can find by using tan theta, tan 25 equal h over 6.88. So h will be equal to 3.21 meters. So When the ball is at its highest point, its height above the horizontal line is 4.92 meters. The height of the ball, that is here, that height is 4.92 meters. I'll raise the question now. We don't need, no, we wrote 4.92 meters. The height of the slope is 3.21 meters. So height of the slope is smaller than height of the maximum height reached by the ball. So the ball will not hit the slope when it is at its highest point. So it will reach the highest point before it hits the slope. I can say since 4.92 meter, that is its maximum height, h equal 4.92 meters, that is greater than the height of the slope at that position of the ball, which is 3.21 meters. Ball will not hit the slope when it reaches the highest point. Okay, next question. A ball is just released from rest from a height of 6 meters above the ground. A gun is kept at a horizontal distance of 4 meters from the line of motion of the ball at an angle theta. So when the ball is released at the same time, the gun fires a bullet at a velocity of u at an angle theta to the ground. At 0.72 seconds, the bullet strikes the ball. So the ball will move vertically down and the bullet will move like this, and the ball and the bullet, or the bullet hits the ball at that point. So the bullet was fired at the moment the ball was released. First part, find the height at which the bullet strikes the ball. So I can find the vertical displacement of the ball, first part. Downwards, I can use S equal ut plus half at squared. So the height it has fallen, I can say initial loss is 0 plus half into 9.81 into 0.72 squared. That will be equal to 2.54 meters. The question is, find the height at which the bullet strikes the ball. So the height at which the bullet strikes the ball, h is equal to, this is 6 meters, 6 minus 2.54, that will be equal to 3.46 meters. So that's the height at which the bullet strikes the ball. Second part, the initial velocity of the bullet is u and the angle with horizontal line theta. We need to find both u and theta. So I can write for the bullet, vertically upwards, s equal ut plus half at squared. So it strikes at a height of 3.46 meters above the ground, means that will be its vertical displacement. So 3.46 equal u sine theta into 0.72 plus half into minus 9.81 times 0.72 squared. So I can find u sine theta from this equation. So the u sine theta will be equal to 8.34. Take it as first equation. Now, when the bullet strikes the ball, it's given in the question the horizontal distance of the gun from the line of motion of the ball is 4 meters. It's given in the question. So the horizontal displacement of the bullet will be 4 meters towards right. So I can use for the bullet horizontally s equal ut plus half at squared, 4 equal u cos theta into 0.72 plus horizontally no acceleration. From this I can find u cos theta. So u cos theta will be equal to 5.5 56. So u cos theta, I'll continue here. U cos theta will be equal to 5.56. Take it as the second equation. So divide the first equation by the second equation. So that will be 8.34 over 5.56. So u and u will get cancelled. Tan theta will be equal to 1.5. So from this, we can find the theta, that will be equal to 56.3 degree. Substitute this value in one of the equation, either 1 or 2. So if I substitute in first equation, u sine 56.3 will be equal to 8.34. Find the value of u, 8.34, divided by sine 56.3. U will be equal to 10 meter per second, 10.0 meter per second. So I know the u, I know the theta, 56.3. So that's the second part. Okay, I hope it will be useful to you. You can, you can send your comments if you want. Okay, right. Bye.